Hey friends, so here we have differential equation to solve and we have to get the solution of differential equation. Now the question is which method we must apply to get the answer of this differential equation. So guys, by looking at the equation, we can say that it looks like a linear differential equation because we know the form of linear differential equation, which is dy upon dx plus py equal to q. So in this case dy by dx is there, but we do not have py and the q, because p and q must be function of x. Okay, so here we don't have that kind of thing, but yes, it is looking like a linear differential equation. So guys, how to solve this? So if we'll do few adjustments over here, then I'm sure that we can convert it into in such a form that it can be reduced to linear differential equation. So how to make such adjustment? So guys, for that what I'll do is I'll divide throughout by cos square y. So here I'll say dividing so by doing this, here we will get 1 upon cos square y, which is sec square y, here we will get x into sine 2y upon cos square y, and here we will just get x cube. So what I did is I removed that y term from the right hand side. That was my objective. Why? Because we can get that q as a function of x. Now let's solve on the LHS. So sine 2y, we know the formula of sine 2y. It is 2 sine y into cos y, and in the denominator we have cos square y. So now here we can cancel this cos y term. So one cos y term from denominator will be cancelled, and sin y upon cos y we will get it as tan y. So here we will get plus 2 tan y into x equal to x cube sec square y dy by dx. And now guys, we can easily say that this equation got converted into such a form that we can reduce it to linear form. Now how? So let's see the form. So this is a concept that we have learned in the previous video, that how to reduce the given differential equation into linear form. So according to it, we should have the f of y term, which we can put it as v, and we should get this derivative. So guys, here you can see that we have tan y term. So if I put tan y equal to v, then the derivative of tan y is sec square y dy by dx, which can become as dv by dx. So I can convert this equation into linear form. So let's do it. So here I'll say put tan of y is equal to v. So that will become sec square y dy by dx is equal to dv by dx. So therefore our equation will become dv upon dx plus, now here we have 2 tan y, where tan y is v, so 2v into x. So here I'll say 2v into x is equal to x cube. Now can you see that we have converted into linear differential equation? So what is the form of linear differential equation? So guys, here we have the form of linear differential equation, which says dy by dx plus py equal to q, where p and q must be function of x, since we have dx in the denominator. Now let's compare it with our case. So we have dv by dx, so our p and q must be function of x. So here I can consider 2x as my p and x cube as my q, and since here we have dv, so v becomes the dependent variable, as we have y as a dependent variable in case of dy. So I'll rewrite this term as dv by dx plus 2x into v equal to x cube. And now if we'll compare it with the linear differential equation, so therefore we can say p is equal to 2x and q is equal to x cube. Now we have to solve this linear differential equation, so we know we have to first find out the integrating factor. So therefore integrating factor is given by the formula e raised to integration of p dx, which is e raised to integration of 2x dx. Now 2 will come outside, integration of x is x square upon 2, 2 and 2 cancel, so e raised to x square. So this is the integrating factor. And now let's find out the solution. So here I'll say therefore its solution is given by, so guys, for solution we'll refer this linear differential equation. So in this linear differential equation, solution is y into integrating factor, because y was the dependent variable, is equal to q into integrating factor into dx, because dx is a variable with which we differentiate that dependent variable. So in our case, if you'll see, then we have v as the dependent variable and x is a variable by which we are differentiating. So here I'll say it will become v into integrating factor equals to integration of q into integrating factor dx plus c. Now let's substitute the values. So therefore it is v into e raised to x square equal to integration of q is x cube, into e raised to x square dx plus c. Now guys, it's just a matter of solving the integration. So how to solve this integration? So to solve this integration, we will put x square equal to t. So here I'll say put x square equal to t. So that will give us 2x dx equal to dt, or I would say x dx equal to dt upon 2. So let's come to the integration. So this will become integration of x into x square e raised to x square dx plus c. Now guys, let's see how I'm converting. So that will be integration, x square is t, so first term will be t, e raised to x square, again x square is t, so e raised to t, and x dx, so here x dx is dt upon 2, so here I'll say dt by 2 plus c, and here v into e raised to x square. Now here to solve this t into e raised to t, we will use the Liet rule or integration by parts. So 1 by 2 will come outside, so here I'll say therefore v e raised to x square, 1 by 2 outside, and now we'll apply the integration by parts. So here we have t into e raised to t, so by integration by parts we will get t, then integration of e raised to t, that is e raised to t, minus integration of derivative of t, which is 1, into integration of e raised to t, that is e raised to t dt plus c. So v e raised to x square equal to 1 by 2 t e raised to t minus e raised to t plus c. So guys, here we got this solution, but if you observe carefully, then we got the solution in terms of v, x and t, whereas our question was in terms of x and y. It means we have to do resubstitution for t and v and convert that given equation or given solution in terms of x and y. So what is the substitution for t? So we substituted x square as t, so we'll resubstitute t as x square. So this will give us 1 upon 2 x square e raised to x square minus e raised to x square plus c. What is value of v? So v is a function of, here v is a function of y, so v was tan y, so here I'll say it is tan y into e raised to x square. And guys, this is nothing but the solution of given linear differential equation. So I'm sure that you understood how to reduce the given differential equation into linear form, and then how to get the solution. Thank you very much.